It starts with silence. The hum of your motor falls quiet. Rust begins to lightly frost your ways, and your oil settles and thickens. The end is coming, and it brings with it one question.
What good are you?
Obsolescence is a cruel mistress. And when she comes for you, it's game over. Welcome back to Inheritance Machining. We're going to have ourselves a little friendly competition. In a machine shop, every tool has to carry its weight, whether that be in a true manufacturing setting where time is money, or just in a small hobby shop like mine where space is at a premium. And with a recent addition to my little cave here, we have to put it to the test. This is an Atlas 7B shaper, and it's a machine for, surprise surprise, shaping metal. This might have you asking, don't all machine tools shape metal? And well, yeah, they do. So the name isn't that great, but that wasn't up to me. The 7 is for 7 inches, which is the largest width of metal that it can both hold and cut, because coincidentally 7 inches is also the stroke length of this reciprocating ram. And this is what makes this machine so cool. Unlike basically every other machine tool that uses rotating motion to do its thing, either spinning a cutter like a mill or a grinder, or spinning the material like a lathe, the shaper uses true linear back and forth motion. But what I don't know is how useful or capable it actually is, bringing me to that competition. We'll use a variety of machines in this shop to produce the same part. Before I can do that though, we have to address the poor state of this shaper. Compared to machines like my mill and lathe that get regular use and maintenance, this shaper has a bit of a disadvantage. So let's give it some good old-fashioned lovin'. And as with any good cleaning, we'll start by making it a whole lot worse first. Now, I just did a pretty thorough teardown in my last video of this neighboring workbench compatriot, and I don't honestly know what good that did me other than eating up the better part of 2 weeks. So I'm going to limit this job to one single day of cleaning. Besides, I'm just really excited to use the shaper for the first time, considering it's also the first time using any shaper. So I don't know much, but I can assume that like a lot of other machines in this shop, the precision surfaces are going to be the most important areas to address, so I'll constrain my focus to the ways, lead screws, and the mounting surfaces. In other words, not a complete teardown. In other words, a side project. Now, we all know that this is a shaper, of course, and that's cool enough on its own. But what's truly amazing about this machine in particular is its history. Or rather, its likely history. I'm a machinist, not a historian. This shaper model started production in 1941, and judging by the very low serial number, this unit in particular was probably manufactured very close to that date. Because most of us weren't around 85 years ago, it's easy to forget that this was quite an important time in history. The world was at war. In fact, the Atlas Press Company ramped up production for the war effort of this exact 7B shaper. But due to its small stature, it probably wasn't making parts for the war itself. Instead, it had its very own important job to do, teaching Army, Navy, and vocational schools basic machining principles. Its small size also made it a vital addition to field repair shops on the war fronts. In other words, this very machine likely helped end the war. It's painful to imagine that this was just kicked around in the later part of its life, bouncing from shop to shop, losing parts in the process, and falling into disrepair. Hardly the ending this machine deserves for its effort or for the men that produced it. But I'm here to give it another chance to shine. Okay, getting a little gushy. Let's get this all back together. Part of taking this apart was to clean out all the dirt, rust, and grime from the ways, so it would be quite a wasted effort if we didn't do something to keep all that gunk out in the future. Normally this is a job for these way wipers, but yeah, need I say more? Luckily, not every tool in the shop is at risk of obsolescence, so let's knock out a little side project with the help of bambulab, the sponsor of this video. This is their X1 carbon, and among the impressive list of materials it can print is TPU rubber. It's perfect for way wipers, and also something I've never printed before, so I'll be trying this together with you for the first time. But what kind of side project would this be without first another side project? Luckily bambulab can help with this too. And finding quick solutions is as easy as browsing MakerWorld, the largest printing platform in, well, the world. It's literally overflowing with designs folks have already put together and shared. So in a matter of a couple clicks and a couple hours, I can tidy up my printing workflow with this poop chute catch bin and a side-mounted spool holder. Both of these improvements allow me to properly integrate this workhorse in its new home within this cabinet. Meaning now we're ready to print those TPU way wipers, which other than mounting the spool out here, turned out to be exactly the same as any other part. The only setting I had to change was the obvious one, the material. And bambulab software took care of the rest. Literally what you see here are the first and only TPU prints I've made. I really can't understate the confidence bambulab brings to printing new things and just printing in general. Even in my shop where I'm largely attracted to machinery of a different vintage, I've really taken a shine to my X1 carbon. At this point I've lost count of how many Gridfinity organizers I've printed, and I don't see myself stopping anytime soon. I can print any size bin I need, which is perfect for sorting and containing all the stuff it takes to really make a machine shop functional, i.e. the tooling. Having everything just how I want it with the flexibility to still make adjustments is a perfect metaphor for what bambulab really brings to my shop. Meaning when I need a better solution for my lathe's specific set of change gears, printing a custom Gridfinity gear holder is the obvious answer. But bambulab is also there for the less obvious solutions as well, like my need for a scale prototype domino. I'll just leave it at that. To see how bambulab can help you on your journey as a maker, use the special link in my description to access their Black Friday deals and to support more projects like this one. I suddenly feel a greater sense of appeal to this machine than I did before. And even better news, this little guy is now ready for the competition. But hang on, what good is a competition if there's no agreed upon set of rules? I guess the word agreed should be used lightly. I'm but one man in his den of pleasures. But I'm a fair man, and what set of rules would a cadre of machines understand better than a set of drawings? Now this is a manual machining channel, and I do prefer to work with my hands whenever reasonable, and sometimes when not so reasonable. But there's one area that doesn't apply: drafting. This is partly because lately my projects got too complicated to draw out by hand, and mostly because I would rather spend that extra time actually machining. But because we're talking about obsolete technology today, and because, well, I love you, let's draft our design for old time's sake. I'll even set the mood for you. For the uninitiated, manual drafting may seem a little backwards. With modern CAD software, you usually play around with a 3D model for a while until you get it how you want, then only at the end do you make your dimensional drawing. But not with drafting. The only product is the drawing itself. By the time you put together your title block, you have to already know what's going to end up on the paper. That begs the question, where is the model? Well, the only place it could be, in your head. We're here to design a part that can be made on multiple machines. This necessitates that the part be kinda simple. This is a fuzzy term though, because what could be easy for one machine could be quite difficult for another. As I usually do when I'm bouncing ideas around in my head, I let some of them land on my wife, all of which she ignored and just said, "What about a domino?" So guess what? We're gonna make a domino. Or rather 3 of them, because I'm gonna attempt to make these on the mill, the lathe, and the shaper. got a variety of features including the square outer shape, the round little dimply-doos, and a slot for the dividing line. And of course some chamfers. Not exactly regulation, but my shop, my rules. Despite this basically being a glorified brick, I do need to include a cross-section so that I can properly annotate the depth of some of the features. Yep, that looks like a domino. Good job, Brandon. The drawing won't be useful without some numbers, so we can drop these on here and some more leading lines so we know what they're actually referring to. Finish up that title block and viola. We have a design. Let's finally get this competition underway. Now I know I said I was excited to use the shaper, and I know I just designed a part I will supposedly be able to make on this machine, but I haven't yet figured out how to actually do that. So let's take a stab at this on the mill. Anyone that's spent 15 minutes in a shop knows that a part like this is the mill's bread and butter. Of course, the precision, which is obviously of utmost importance for this part, completely depends on how square the starting material is, so we have a little work ahead of us to get there. And while this may not be a terribly complicated part for the mill, I think we can try to make this special by really aiming for a perfect finish. This face mill isn't going to cut it though. For a truly fly appearance, we need the fly cutter. Yeah, now that's what I'm talking about. It's not just tools like this at the risk of going obsolete. It's also the techniques used to run them. A lot of the tricks of the trade, as you call them, get lost when the trade gets lost. So the only way you can learn them is from former tradesmen. Take this for instance. Normally by this point in the squaring process, I would use a precision square to orient the part so I can cut the fourth side perpendicular to the first three. But I once met a retired machinist named Bruce that told me there's a much faster way. Just clamp the part at a slight angle to cut the fourth face. While it doesn't make a square face in one direction, it does make a perfectly square edge in another. So I can just put this new edge down on the parallel underneath, cut the other end square, then come back and clean up the original slanted end. And boom, 5 out of 6 faces are now square and not a single square was needed. All just using the squareness of the machine itself. The last face I trust is obvious. Alright, time for some features. Exchanging for the finder of edges, it does its job. Then I can pop a ball end mill in for those dimply-doos. That's pretty satisfying. But now for something a little risky. This 16th inch end mill is the smallest I own and the smallest I've ever used. So I think it's going to pay to take this nice and slow. 5 thou cuts are plenty deep enough, especially considering I only have this one slot to do. Looking good, but not as good as it will after a nice set of chamfers. With a uniform thickness part like this, chamfering is a simple task, then rotating the part through all the edges to get them nice and even. That turned out incredible. You could almost say this mill knew what it was doing. That's probably why nearly every machine shop has a Bridgeport style mill like this still floating around. You just can't deny that effectiveness. But I think that's enough gushing over this machine. We can't play favorites, at least not yet. On to the next competitor. With how quick we just whipped up the mill domino, I didn't really get a chance to give the shaper approach any more thought, so let's see how we can fare on the lathe. I know what you're thinking though. Brandon, aren't lathes meant for making round parts? And well, yes, they sure are. But with a little out-of-the-box thinking, really anything is possible on this machine. We will start with some round stock, just for funsies. This opening move is not an uncommon scene for a lathe, facing the end, then parting off and facing the other. And that's 2 of our 6 faces complete. For the remaining 4, it's time to leave that box. This 3-jaw chuck might be alright for holding this bar sideways, but it would really do better with an extra jaw. I have some copper soft jaws on here, but with this brass, that still isn't soft enough, so let's take a moment to make them softer. Alright, that ought to do. The parallels do a good job getting this bar square in the machine, but again, this is a game of appearances too. I really want the circular pattern to be centered on the part. It's a small detail, but worth the time to properly indicate it. In two directions, of course, end to end and side to side. I made that look easy, but that was like 5 minutes of fiddling. Anyway, with that now squarely on center, let's turn this into a rectangle. Man, that last face was a close call with the chuck, but clearance is clearance, Clarence. And just like I hoped, the time I took to center the part on each step was worth it. That looks fantastic. Now let's address all the other dominoes details. These are easy enough to mill because I had the axes of the mill's table to play with. That might be possible to replicate with the 4 independent jaws of this chuck, but the chances of keeping everything straight from dimple to dimple are total shit. So what do? How about instead of trying to hold the part in the chuck, we hold the part in a tool holder? You probably see where we're headed now. We're going to use this lathe like a horizontal mill. The first step, of course, is to find the edges of our part. The x-axis is easy enough to do because we have a cross-slide hand wheel, but the y-axis is pretty finicky because all I have to play with is this adjustment nut. I will give it an impromptu scale though with this dial indicator so I can at least maintain a decent amount of accuracy. Alright, let's mill with our lathe. As my British friend Eric would say, I'm quite chuffed with that. Now we have our next hurdle. We have to somehow mill the slot. And trying to manage that while moving this tool holder nut is a surefire way to make this look like ass. So what if instead, we just used a tool holder to hold our tool holder? That's some out-of-the-box thinking right there, let me tell you. Of course, that's what you don't see right away that ends up being the problem. How unhelpful. Luckily, the solution is just a slight change of angle. And we're in the clear. And more importantly, square. Another cleverly positioned dial indicator, and we can set the vertical offset for that dividing line, once again using our itty bitty phriend here. Just like that, we've got ourselves a brass domino, but it's missing something. It just wouldn't feel right without a proper chamfering. It's on the drawing after all. Other than some funky setups holding our little polka dotted phriend here, the process of working through all the edges is the same. This all just goes to show how versatile lathes really are. A machine specifically designed for making round parts, and it still does a fantastic job making the squarest of square parts, all without any sort of special tooling or fixtures. And that looks fantastic. The only giveaway that this was made on a lathe instead of a mill is that telltale swirl in the middle. Good job, my old friend. Alright, there's no running from it now. I have to figure out how to make this domino on the shaper. I have seen a couple YouTube tutorials though, so naturally that makes me an expert. First and foremost, we need a way to hold the material. Probably wise to go ahead and put the vise back on here. Of course it needs to be square with everything, so a quick tram with the indicator mounted on the ram makes sure we are lined up with the cutting axis. Which brings me to the next part. We need a cutter. These are pretty much the same as a lathe's cutter, so let's just use one of these. I will put a disclaimer in here that I'm using a carbide cutter, which wasn't even a thing when this machine was in its heyday, so this may or may not work. Only one way to find out. We need to make sure the stroke of the machine is actually long enough to cut the full length of the part, which is a simple adjustment with this knob and this square drive thingamajig. The second component to the ram setup is the actual position. Another simple adjustment, loosening this locking handle and shifting the whole ram with this other square drive. Last thing before giving this the juice is setting the cutter zero with the top of the part. The rough adjustment is made with the elevator screw bringing the vise up to the cutter, and the cutting depth is made with the tool slide hand wheel up here. Okay, I think that's everything. Let's send it. Hey, it's doing the thing. Now that is quite satisfying, and not just because it didn't blow up in my face. This is just so mesmerizing to watch. You can actually see each of the chips form one by one. One sliver is separated from the block before retracting and somehow magically relieving another and another. The surface finish isn't all that great though. Luckily we were really just doing a roughing operation. Adjusting the position of this connecting arm on this slide will help. This effectively reduces the step over with each pass. And since we're using carbide, let's go ahead and increase the machine's speed to see if we can get a better cut. Yeah, buddy. Now that's what I call a finishing pass. I don't mind the extra time it took to get across the part, so let's go ahead and just stick with these settings for the rest of the faces. I think it's safe to say I could watch this for hours, but we do have to pay attention to what we're actually doing here. We want this to be a specific dimension after all. The depth gauge isn't the traditional method to check this, but a verification with the caliper proves it was spot on, and more importantly, these faces are parallel, within 1/1000th of an inch. Not bad for a machine 85 years young. Let's go ahead and knock out the largest faces now. As entertaining as this is to watch, I will say I understand why you basically never see shapers being used anymore. It really is just so slow going. With nearly half of the machine's movement not actually removing metal, this is no surprise. This squaring process would have been long complete in the mill. And I think that would be the case for an actual production size shaper as well. Even still, this little guy is hanging in there. And the surface finish is delicious. All of the cutter marks being straight and parallel like this, mwah. It's a small detail that most folks wouldn't even notice unless you're familiar with machining processes. If you presented a part to someone with a cut pattern like this, it's a bit of a subtle flex that you managed to make it on a shaper. Which will probably only be cool to you, but does anything else really matter? In all the excitement, I forgot to actually use lubrication for these cuts, and wouldn't you know, it actually made it better. Not tremendously, I'll add, but definitely enough that I'll keep using it from here on out. But from here on out does raise a question because now we have the two ends to take care of. Standing this up in the vise feels like a bad idea. That, and I just want to mix things up a bit. Let's get the vise off here entirely and clamp this sucker right to the side of the table. This time I actually do need to bust out that precision square, but what can you do? Let's hope these clamps are strong enough to hold this little guy. We just need to clear the rough mill finish on this side with a light pass, and one more for good measure. I'll have plenty to remove on the other side. We'll flip it over and start on some even heavier material removal. Well, so much for that. I should have known better than to push the limits so early on. The real question though is, do I still have enough material to disappear that little whoopsie? Looks like we're in the clear. Let's just take this nice and easy while we finish out this side. Bang on. Now that's what I'm talking about. 3 for 3 on the dimensions. All that work just to get to the starting point of the block. We haven't even added any of the features. I know we saved the chamfers until the ends on the other 2 blocks, but I guess you could say chamfers are one of my vices. I'll set the cutter angle to the traditional 45 degrees and we can get to work. This is pretty straightforward. I'm just advancing the material by hand. This gives me a lot of control, or at least the illusion of it. This axis doesn't have any kind of scale on it, like nothing at all. The best I got is to eyeball the size of the chamfer until it looks about the same as the other 2 dominoes. Then just remember that position on the crank and return to it as I work my way around the edges. Doable, but far from precise. Alright, there you have it, a domino. But you might be noticing something odd about this one. It ain't got no dots on it. This is where I have to confess something. I knew all along that this machine wouldn't be able to get the job done. I know. I set the rules, but I wanted to prove a point. I wanted to show why this machine is basically not even worth its weight in scrap for most of the world. It can't even make something as simple as a domino. Clearly a mill is a much better tool, hell even a lathe could manage. I suppose we could try something like using the ram like a hammer to beat the dots into the face, but then I still have the divider line. And well, I just don't want to abuse this machine any more than it already has been. So I guess we can't go any further. But wait, what's this? We have someone stepping onto the floor. The pantograph is willing to be the alternate. This is remarkable. We've never seen this kind of sportsmanship before. Let's see if the old decal can manage this recovery. One thing that can be said about a pantograph is that it's a very versatile machine. It can copy almost any 3-dimensional part, but it does come with its own set of limitations. For one, this model doesn't have the ability to do true one-to-one duplication. So using one of the already completed dominoes as a template is out of the question. That doesn't mean we're SOL. I happen to have a 3D printed domino right over here. It's a perfect 3-to-1 scale of what I want this domino to look like. It's almost like someone was planning ahead. Anyway, because we know the scale, we can easily adjust the arm positions to match that scale. But that doesn't mean we're ready to go. I'm going to use a ball end mill like we did over on the mill for the dots, but something you have to always keep in mind when using a scaling machine like this is that when you scale the part, you also have to scale the tooling. What does that mean? Side project time. We need to whip up a stylus for the tracing side of the machine that is an exact 3-to-1 scale of the cutter we are using, i.e. a ball stylus. Of course, we don't have a ball turner in this shop, at least not one that works, so a little file action and a radius gauge will have to do. Let's get this in the machine. Coincidentally, I have to set the height of both the stylus and the ball end mills such that they're even with the center line of the pantograph's pivot arm. The pivot arm that, once this locking bolt is removed, gives me full 3-dimensional range of motion. So we're ready to actually cut this thing, right? Wrong. Just like every other machine setup, we have to locate the part. Otherwise, we could pop some dots on here in the complete wrong spot or not on the part at all. Holding the cutter along the edge of the template, I can bring the part over until it just brushes the end mill. Then repeat for the other direction, and of course the height as well. And now, finally, we are ready for dimplification. If there's one thing that this competition has shown, it's that no machine is truly an island. They each hold a special place in the world, but they also wouldn't exist without each other. The mill did a fine job making the domino by itself, but who do you think made the mill's spindle? Not a mill. The lathe even managed to get the job done in the end, but what machine do you think made the long bedways? Not a lathe. So when I need a shaper and then a pantograph, and even then a lathe and a 3D printer to make a domino, this is just how the world works. Even a modern CNC that can produce any shape of part can't do everything on its own. There's a whole economy that makes what these modern marvels can do possible. Even this shop has its own scaled down economy. That's what's so neat about this wonderful world of machining and why I keep making videos about it. There's a connectedness to it all, and those connections create a network. A network of nearly infinite possibilities for making a part, solving a problem, and most importantly, telling a story. How beautiful to watch these two machines, both nearly centenarians, work their magic in a way you just don't see anymore. In my shop, I'm not after speed, capability, or efficiency. I'm after an experience. The shaper might not have been able to make a full domino, or even half of one very quickly, but it was damn cool to do, and watch. Outdated or not, these machines will always have a home in my shop. And all this little competition proved is that obsolescence is in the eye of the beholder. And the best machine for the job is the one that speaks to you. As always, thanks for watching, and see you next time.